right, we are going to be working on lesson 1-7 today, the distributive property, okay? Okay, distributive property is defined as multiply the outside number, so an example here on A would be 3, outside number, by what is inside the parenthesis, okay? So multiply the outside number by what's inside the parenthesis. So let's zoom in here on 1A, okay? And so what we're talking about here is we're going to distribute, we're going to multiply the 3 through, okay, to both parts, and you're going to multiply by everything on the inside. So 3 times x is 3x, 3 times 8 is 24. Okay, go to the next example here on B. Okay, now, we don't care if the number by itself is front or back, so in this case, we're going to take that -7 and distribute it through to the 5b and get negative 35b. And then we're going to take the -7 and we're going to multiply it by the -4. A negative times a negative is a positive 28. And that would be your final answer. All right, so yes, we are going to be doing a little bit with some fraction work, okay? And we reviewed that earlier in earlier lessons. We're going to go ahead and distribute the 12 through. So 12 times 3 is 36. Minus, okay? Now, if you need to do a little scratch work off to the side, that's okay. 12 times 1/6, okay? And then the 12 and the 6 cancel to a 1 and a 2. Now, if you need to put the 12 over a 1, you can do that. So then 2 times 1 is 2. So when I distribute this, I'm going to end up with minus 2y. Okay? All right, next example here. Okay, so now just looking at one with decimals, same concept. Again, we don't care if the number's out back. We're going to go ahead and distribute that 3 through to both parts, okay? 3 times 0.4, well, 3 times 4 is 12, and you have one decimal here, so that means you're going to move it one decimal over. So we're going to get 1.2 plus, and then I'm going to multiply 11 times 3 and get 33. Again, one decimal, so I move it one over, okay? So plus 3.3c. And this right here would be your final answer. Okay. All right, next one. All right, so now on some of them, they've thrown out a variable out front instead of a number. It doesn't change the overall concept. You're still just going to take the -y and drop it in to the 2y, and then you're going to drop it into the -1, okay? So when I take -y times 2y, just keep in mind that in front right here, there is a -1, okay? So when I distribute that, a -1 times 2 is -2, and then y times y is y squared, okay? You may or may not have already been taught that. So anytime you're multiplying two y's, you'll just get a y squared. And now I'm going to take that -1y times the -1 on the inside. A negative times a negative is a positive. 1 times 1 is y. Sorry, 1 times 1 is 1, and then you have the y left. Now, you cannot put these two guys together, okay? Y squared and y cannot be put together because they have different exponents. And we're going to talk about that in more detail here in just a little bit. Okay, so this right here would be your final answer. Okay? All right, let's go to example F. All right, anytime you see a negative on the outside, no big deal. It is technically saying that there is a -1 there. Okay? Or you can just kind of think about pushing that negative through. So when I take a negative times a negative, I'm going to get a positive. 1 times x is x. And then -1 times 36 is minus 36. Now, keep in mind, I'm okay if you want to call this a 1x because that's the same thing. Either one of those answers would be correct. Okay? All right. We are also going to take a look at what happens when instead of putting the number out front, they choose to put this number down on the bottom, okay? So it's still kind of like distributing. This 5 goes with the 7 and with the 5. We're just going to break it up. And by break it up, I mean we're going to write 7 over 5x. Again, it doesn't matter if you want to put the x out to the side or if you want to call it 7x over 5. It's the same thing. Either one of those would be good. Okay, plus, and then you're going to break that up to 2/5. So again, the 5 goes with both parts, So this right here would be your answer. Again, if you want to write it with the x on top, that is fine. All right, so now let's take a look. Oh, also keep in mind, if you can reduce these, you need to. 7/5, 2/5, they don't go anywhere, so we don't have to worry about that. So on B, when I break this up, okay, I'm going to put 4/8 minus 2/8 x, okay? So again, I've got this guy and this guy. That 8 goes to both parts. So 4/8 is 1/2 minus 2/8 reduces to 1/4 x, okay? This right here is going to be your final answer. You have to make sure you reduce fractions, okay? It will be wrong if they're not reduced. Next example, letter C, okay, same thing. We're going to divide both of them by 4. So I've got 4x divided by 4 minus 16 divided by 4. Again, both the 4 on the bottom goes with both the top parts. So 4 divided by 4 is 1, or these just kind of cancel out, and you have an x. If you want to put a 1 in front, you may. Minus 16 divided by 4 is 4. So that would be your final answer, x minus 4. All right, couple vocab words. Term is a number, a variable, or when I multiply, product means multiply a number and a variable, okay? So an example, all of these would be terms, okay? Let's put down a couple examples here. So if I have like 4, that is a term, it's a number. Negative 18, that's a number. A variable, x, a. I don't even care if there's 2 variables, so it could be x, y, okay? Or when you multiply a number and variable, so like 3x, negative 16xy. All of these are considered terms, okay? So again, a number, a variable, or a couple variables, or a number times a variable. And like I said, you can have more than one variable there. So let's go ahead and kind of backtrack here. And maybe we should put a number. I'm going to put apostrophe S, maybe, okay, apostrophe S here for variables, because it could be more than one, okay? So a constant then is a term that has no variable, okay? So a constant, an example of constant would be right here. Basically, they're just numbers. It's another word for a number, okay? Coefficient, the numerical factor of a term, okay? Numerical factor of a term. Again, a term can be any of these. A numerical factor has to be a number in front of a variable. So, and that's what I put right here, a number in front of a variable. So an example here of what we would have. So if I say 4x squared y, okay, that is a term. It doesn't matter if there's exponents. There's allowed to be exponents. That's okay. Okay, but the numerical factor or the coefficient is 4. So if I have like negative 1/2 a, your coefficient would be negative 1/2. If I just put x, well, since I didn't write any number, but we always know that there's a 1 in front of any letter, so my coefficient here would be 1. Okay, so coefficient, number in front of a letter. All right, let's move on to page 2. Let's go and flip over. Okay, a like term. So now we're looking at the terms, and a like term have got to have the same variable, and I'm going to go ahead and put apostrophe, parenthesis s here, or variables with the same exponent. Okay, so it has to have the same letter and the same number of an exponent. So let's take a look here at A. So when I look at these, the first thing I've got to ask myself, do these have the same letter? Yeah, they both have x's. Are the exponents also matching? Yes. If they are, then you can simplify and call it 8 plus 2, 10x squared. Okay, basically, guys, all we're doing is adding the numbers in front. Combine like terms. Okay, so let's take a look at this one. So if I'm combining like terms here, I have a 5x and a negative 3x. I have a negative 3 and a negative 4. So I'm combining my x's in red there, and I'm combining my numbers, which are in blue there. The poor 6y, this little guy right here, he doesn't have anybody to pair up with, okay? So let's go ahead and combine the x's. 5x minus 3x is 2x. Negative 3 minus 4 is negative 7. And then plus 6y. Now, please note, it does not matter what order these are in, just as long as you have all 3 parts. So if I wanted to say 2x plus 6y minus 7, that would also be an acceptable answer, just as long as you have all the parts. Okay? All right, C. Okay, so now on this one, we've got a number outside the parentheses that we're going to deal with first, and then we'll clean things up. So first thing I'm going to do is I'm going to distribute that 2 through. So I get 6x minus 10 plus 8x. Then I'm going to combine like terms. So the only thing that can go together would be the x's. So 6x plus 8x is 14x minus 10. And that would be my final answer. Okay. All right, let's go down to D here. Okay, so D, obviously these are the combined like terms. These are like terms. They both have a y. But keep in mind that there is a 1 here in front. So this is actually saying 3 minus 1, which is 2y. Okay. E. All right, so now when we look at this, we got to be a little more careful now because we have lots of letters. So we have M and M. Those look good. N to the fourth looks good. So I'm going to go ahead and combine these. So -7 and -5 would be -12. And then just write down M, N to the fourth. And that's going to be your answer. Okay, and then let's go to F. All right, now we really got to be careful here because they're going to try to trick us up. So y to the third z, y to the third z. This guy's no good because he doesn't have a y to the third. It's z to the third. So this guy cannot be combined. So I'm going to combine y to the third z and y to the third z. Again, remember there's a 1 in front. So we're going to end up with 8 y to the third z minus 6y z to the third. Again, this guy didn't have anybody that he could attach to, so we just rewrite him down. And this right here is going to be our final answer. Okay, that concludes the notes for lesson 1-7. If you have an assignment that you need to complete now, go ahead and do so.